Assalamu alaikum, students. Last week in science, we started with a new chapter that is states of matter. And you all must have read about the topics that are present in this chapter, right? That what is actually a matter, how many states of matter are there, what are different properties of matter, right? We discussed about it. So, in this video, we will only be doing a revision. Okay. Now, first of all, what is a matter, right? What is actually a matter? Matter is anything that occupies space and carries weight. Okay. So, something, since they're saying it occupies a space, okay, so you need to feel it in that way. Okay, you need to observe it in that way, that for example, if I am talking about let's say I'm talking about chairs. Okay, so a chair is occupying a space, right? And it also has a weight. It's heavy in weight, right? So this is a matter. So matter is anything that occupies a space and it has a weight, right? Now on there are three types of matters basically. One is solid, one is liquid, and one is gas. Okay. Now, these three states of matter, they have different properties. Why is it important for us to learn different properties of these matters? Because only by the help of these properties, we are able to differentiate between them, right? With the help of the properties of each of them, we are able to tell that yes, this is solid. Okay, for example, a chair is solid, right? Water is liquid, steam is gas. So how do we know? We know this only by the help of the properties. Okay, now see, here these three states of matter are shown, and this is your book only. Okay, so you can see it in your book. Three states of matter are shown. This is solid, right? This is liquid, and this is gas. Although all these three of them, they are matter, right? They are one and the same thing. All of them are matter, but solid is different, liquid is different, and gas is different. So how are we able to tell that these three are different from each other? Only by the help of their properties. Now look at this picture. Okay, I have drawn it for you. First of all, we will be discussing about the properties of solid, right? Now this is a container. Okay, this is a container, right? First thing that you should know about solids are that solids have fixed shape and fixed size. Okay, how can I explain you this? Okay, let me give you an example. Since I'm saying that it has fixed shape, I need to clarify it. Now how am I saying that it has fixed shape? For example, if we talk about a wooden block, okay, let's say a wooden block, the wooden block has fixed shape, right? Can it change its shape? No, it cannot. Okay, if you drop it anywhere, the shape will remain the same, right? Then comes the example of a chair. Okay, the size of the shape of the chair is same. The shape of the chair is fixed, right? If I place chair, if I for example, if the chair is dropped accidentally, does it the size changes? Do you see a change in the size? No, the size, sorry, do you see a change in the shape? No, the shape remains same. Okay, and the size also remains same. Yes, things can break. Okay, now this is completely a different thing. That let's say we have a glass. Okay, it's also a solid, right? And it also has a fixed shape and fixed size, and if I drop it, its shape changes, okay, and its size also changes, it becomes small. That's another concept, okay, because why the size and shape changes? Because it has broken down, okay. So do not confuse these things with the actual concept of the properties of solid, okay. That is completely a different thing. Whenever we are talking about the properties of solid, the two important things that we should remember is that they have fixed shape and fixed size, right? If a glass of water, for example, if an empty glass is present on a cupboard, right, it is present inside a cupboard, the size is same, and if I place that same empty glass in a freezer, and if I take it out, still the size remains same, right? Sorry, the shape remains same. The shape is constant, okay, and the size is also constant. The size doesn't alter, the size doesn't become small or it doesn't become larger, okay. So this size and shape remains fixed, okay. And here you can see the arrangement of particles. Now what are they called? Okay, you can see there are a lot of particles. Now what is this small one called? It is called an atom, okay. What is actually an atom? See, atom is anything, okay. Atom is the smallest possible structure of matter. Atom is the smallest thing that makes up a matter. All of the matters are made up of atom, okay. All of the matters are made up of atom, and atom is the smallest thing of the matter, right? Now when uh, one atom combines with or attaches itself with another atom, it becomes a molecule. What is actually a molecule? Molecule is something in which when more than one atom is present, okay, it is called as molecule. So matter, if I say that, if I ask you that please tell me that is matter made up of atom or a molecule, you will say that it is made up of both. Why? Because a molecule is made up of atoms, okay. Matter is made up of molecules and molecules are made up of atoms. So indirectly the matter is made up of both molecules as well as atoms. So here you can see that the particles or the atoms, they are tightly packed with each other. See, they don't have any space to go anywhere. They are tightly packed with each other. There is no distance between them. And because the atoms are arranged in such a way that they are tightly packed with each other, that is why, this is the reason that solids have a fixed shape and fixed size. This is the reason, basically this is the most important reason, because the atoms are so tightly packed with each other, they are so closely packed with each other. This is the reason that solids have fixed shape, okay. Now we will be talking about liquids. Now in the case of liquids, liquids do have fixed size, okay. They do have fixed size and volume, but the shape is not fixed, okay. The shape changes. Now when I say the shape changes, I will give you an example how. If water is present in a jug, okay, it takes the shape of a jug, right? When water is present in a glass, if I pour water from that jug into a glass, it changes its shape into a glass, right? So this tells us that, and since we know that water is a liquid, so this tells us that liquids do not have fixed shape. And you will observe this type of phenomena, this type of example with every other liquids. Let's take juice, cold drinks, other things as well. They never have fixed shape, okay. They take the shape of the container. And why is that? It is because the arrangement of the atoms are like this. You can see the space between them, okay. They have few space between them, okay. There is few distance between them, so the molecules can move, right? They are molecules, okay. This is a molecule, why am I saying it a molecule? Because see, this smallest
unit or smallest possible thing is called as an atom. And here I can, in this one I can see more than one, so it becomes a molecule. Okay, so that is why I'm calling it as molecules. So here you can see that the molecules are present. Here you can see that the molecules, they have some space and some distance between them, and that is the reason that the liquids can flow easily. Okay, for example, if accidentally you spill a glass of water, you can see that how conveniently and how easily the liquid flows, right? So this is because of the arrangement of these molecules. They have distance between it, right? But liquids do have fixed size and volume. Okay, how am I saying? First of all, what is volume? Okay, volume means that it takes up space. Okay, it has a weight. Now when I say that liquids have fixed size or fixed volume, okay, in the case of liquids we use the term volume, right? We don't use the term size. Remember this. In the case of liquids, we use the term volume. Okay. So since I'm saying that liquids have fixed volume, okay, how can I give an example? Now see, for example, if you weight a jug of water on a weighing machine, and if you subtract the weight of the jug from it, right? Okay, forget the example of jug. Look at this example. Please ignore my drawing. See, if I weight a glass of water, okay, this is a glass, this is the water, and this is my weighing machine. When I weight the glass of water, and if I subtract the weight of glass from it, okay, so the weight of water in this case, and in this case, that when I pour this water from the glass into a container, okay, this is a container, I am pouring all of the water from the glass into the container, and then I am weighing that container on the weighing machine. So if you subtract the weight of the container and you only take the weight of, and you only measure the weight of the water, so in this case the weight of water will remain same. Okay, if you are weighing the water, if you are taking a glass and you are weighing water on it, you have water in it and you are weighing that glass, so and after weighing you subtract the weight of glass from it. Okay, you're not subtracting the weight of water, you are only subtracting the weight of glass from it, right? And the weight of water in that case, and in this case, that when you pour this water, all of the water from the glass into the container, okay, and you weight it on a machine, a weighing machine, right, and you subtract the weight of container from it, so in this case the weight, and then comes the weight of water, so in this case the weight of water will remain same. Okay, so this tells us that liquids have same volume. Okay, they have fixed volume. Right, now I have the last type of last state of matter, that is gas. Okay, in the case of gas, neither they have fixed shape of its own, nor they have fixed size of its own. Okay, the shape and size changes, right? For example, if I'm saying that they do not have a fixed shape of its own, when you blow a balloon, okay, it takes the shape, the gas that you have blown in it, right? You can see that it takes the shape of the balloon, right? Now if I spray a perfume, okay, first of all, can you see gas? No, we cannot. Most of the gases, we cannot see most of the gases. Okay, they're invisible, right? Now if I spray a perfume in a room, so it takes the shape, it doesn't have a fixed shape. Okay, if it would be having a fixed shape, we would be able to see it through our eyes, right? But it doesn't have a fixed shape. And why is it? It is because of the arrangement of the atoms in gas. They are two apart. They have a lot of distance and a lot of space between them. Okay? And they can freely move from one place to another. Remember that the movement of the gas particles is fastest as compared to the movement of the liquid and solid. Okay, one example is that when if you spray perfume at one corner of a room, immediately you can smell the fragrance at the other corner of the room. So you can observe this thing that the molecules of you can observe this thing that gases travel faster, and that is mainly because of the arrangement of the molecules and the arrangement of the atoms, arrangement of the atoms in this case. Okay, why? Because they have a lot of a space and a lot of distance between each other. You can see the difference clearly. Okay.